So the second part is conversion of the 6 meters to 4 meter or 2 meter and 1 meter. Then getting the units of an arc going to subtend. And so um the catch to convert 6 meters to 4 meters or 2 meters or even 1 meter sometimes is that let's say you have a output of 636 now. Okay, and then since of course these are 16 meters, let's convert to 4 meters. So you you just say six when a normal person at 6 meters away, the meaning of the 6 meters is that when a normal person said at 6 meters away, you're able to see the T6 line. Or they're able to see the line as the Texas, I mean the letters at the Texas meters. So the testing distance is 6 meters there, okay. But it means that we expect normal person that is saying at the same time to be able to see that. For now, we want the testing distance of 4 meters. And so we want to know how much is going to give because it will reduce if we reduce the testing distance. So that means the normal person to staying at 6 meters away will have to move closer. And so we just say that at 6 meters. And so the x meters will be 4. And so it's equal to 12 times 36 divided by 6. And that will equal to 4/24. So that will be no 36 times that will be 24. I mean, okay, so that will now be 24 meters. And so 636 now equal to 4/24. And so that's the conversion there. So you could also do for, let's say, 6/24. Let's say 6/9 or something. And so we just that 6 plus 9. I mean, when we're testing at 6 meters, we expect so it is 9 meters away. Now I want to test at 4 meters. How long would the person stay? 6 will now equal to 4 times 9 divided by 6. And that will equal to 4 times 9, 4 plus 6. That will equal to 6. And so 6/9 should be equal to 4/6. Then convert to 4 meter. Can you see? So that's 30. And so um we could also go back and forth. The logman will also be the same thing. So let's do the 2 meters too. We can do the 2 meters. Let's say like 6/24. We want it to be a 2 meter chart. So we just do again at 24 meters or 6 meters anyhow. We want that person 24 meters to be able to see. So I am testing at 2 meters. Um, how long that can person be? So x now be equal to 2 times 24 divided by 6. And now equal to 6 and 24 before times 2 that will be 8. And so 6/24 to the equal to 2/8. And if you see that even the vsauce will be the same thing. The vsauce is when you divide the units. This notation is when you divide 20/20 to be 1, so versus be 1. Even in 4 meter chart, the vsauce will be 1. And the logma will also be the same thing because the mile will still be the same thing. So everything should be the same, whether a 4 meter, 2 meter, 1 meter. Okay, so this one now, the mile will have been what's it, 24 by 6, 44. Even the mile to overheat is in there to overheat. The mile to overheat, brought to 8 over 2. So that was equal to 4. So that shows the mile should be the same thing, whether it's in 2 meters, 4 meters, or even 1 meter. Let's do the 1 meter one too. That's the location that's 660. And then you want to convert to 1 meter distance. So just since 6 meters, one person should have to stay 10 meters away. So if another distance is 1 meter, how long can that person say? X will now be equals to 60 times 1 divided by 6. I'll put it there. So for the 1 meter, 660 equals to 110. And so that is that about that one. So you can play with it and do multiple calculations. Also do like that, you see it at the same time. And then the idea is that the mass to be the same thing. Mm, the mass will be the same thing. Also, you can test either 4 meters or 6 meters, the mass will be the same thing. So the plasma will also be the same thing. Can give an example for that. Let's say you have, let's say, it will hit one to the other than generally. So you see here, can see this 18, the mass will be 18 over 6. That would be when you convert to 4 meter. No, so the 4 over 12. And 12 over 4 will be 30. So log 30 will still be 0.48. So that's the how to convert from the 4 meters, 2 meters, 1 meters, and down. It's not really too advanced. I mean, too relevant to low vision actually. So that's where that will be relevant. So the next thing is the angle, the ax minutes that we should say. So how to you do that? So what happens is that for each letter after type, it's just 25 minutes of arc. This is very important to separate from the previous video. So the 5 minutes of an arc, um, each prototype actually something 5 minutes of an arc at the average lesson distance. So let's say 20 over 80, for example. So this is in feet, right? So we expect that those data that are in that 20 over 80 is for 25 minutes at 80 feet. That's the meaning. To stop 25 minutes at 80 feet. So if you want to know X minutes at 20 feet, what would that be? So, but how we did is that you divide the 80 by the 20. You know, the 80 feet is 5 minutes. All of them is to spend 5 minutes at the appropriate distance that patients, normal person is supposed to see. You know, the 28 minutes that normal person is supposed to see at 80 feet away. So, and that will be 5 minutes for that normal person to be able to see. Now, you want 20 feet now. So, at that 20 feet is not 5 minutes again. How to now divide this out? You divide the feet, the distance by the testing distance. So, distance normal person should see by testing distance. So we now expect, so that will now be, you expect my to say at 80, then by testing distance, that is 4. So you now multiply that value, then multiply by 5 minutes per hour. So that will now be, so far as at 20 feet for that question, so we got to 4 multiplied by 5. And so it's now for 20 minutes of arc at 20 feet. Okay, let's do another example. Let's use 6 stem around. It's like 660. So again, we expect normal person to be able to see 60,000. So that 5 minutes is sustained at 60,000 because that's what we expect normal person to be able to see clearly. Each limb will be 1 minute, so the whole limb will be 5 minutes. So they must sustain at 60 meters before able to see clearly. So now, um, that's 5 meters, 60 meters. Now to get at 60 meters, what you do? You define what you expect normal person to see 60, whereby testing the standard what was 10. Whatever you get, so multiply by the 5 minutes per half. 5 minutes. And that will equal to 50 minutes per half. So that's how to calculate that. So again, you define the distance you expect normal person to see, whereby six. Now give you whatever you get multiplied by the five. So that will be the five drawn up. So we can try one here. One else, and there is one here. So this is 2040. That's 612 being converted to 6 meters. So we expect it to just to spend normally at 14 feet. We expect 5 minutes. Because again, this one is don't forget is 612 or 2040. 240 feet. So that means we expect 5 minutes at 12 meters. But that was the automatic percentage we see of 40 feet. And so at 6 meters, what do we get? So just use 40 divided by 6. No, 40 divided by 20. You know, it's that will be in feet or 12 divided by 6. You know, that will be equal to 2. So you now multiply it by 5 minutes per half. So that will equal to 10 minutes. And so that means 10 minutes will now be at 6 meters, and that's what the number is. So it will be 10 minutes at 6 meters or 20 feet. So that's how to get that. So this is actually the correct way of doing that. Um,